Hi guys, here is lesson 96. It's called Graphing Quadratic Functions. If you'll remember, quadratic means that you have an x squared. If it doesn't have an x squared, it's not a quadratic function. Quadratic function graphs are always in the shape of a parabola, which is a u or an upside down u. So the important thing for all of these is that they must be in standard form. If you'll remember, standard form is y equals ax squared plus bx plus c, or we could have f of x, which is just another name for y, equals ax squared plus bx plus c. So when we're graphing these, there are 5 different things that you're going to need to do. So you might want to write these down. The first thing is to find the axis of symmetry. If you'll remember, symmetry is when if we cut something in half, we could fold it over on itself and they would be mirror images of each other. So the equation for the axis of symmetry is x equals negative b over 2a. If you look back at our standard form, we would have negative b and then we would have 2a. That will get us our axis of symmetry. The second thing we want to do is find the vertex. So we're going to use the axis of symmetry for the x coordinate of our vertex. We're going to plug that x coordinate back into the equation and then solve for y. That will give us our vertex. Step 3 is to find the y-intercept. You can use the c value, which is your last term here, or you could substitute, sorry, I had a spelling error there. You could substitute 0 in for x and then solve for y. Step 4 is going to be to find one point not on the axis of symmetry, and then we're going to graph everything. So it's a long list of steps. Let's do an example and see where it gets us. All right, so step 1, is it in is it in standard form? So we have y equals ax squared plus bx plus c. So my a value for this is 1. If there's nothing in front of the x squared, we're going to assume it's a 1. My b value is 6, and my c value is 8. So in order to find the axis of symmetry, I'm going to use the formula x equals negative b over 2a. All right, negative b would be negative 6 over 2 times a. Well, a is 1. So negative 6 over 2 times 1 is negative 3. So my axis of symmetry is that x equals negative 3. All right, step 2 is to find my vertex. Remember, the vertex is the maximum or minimum point on the parabola. So it's going to be a coordinate, right? I already found my x coordinate right here at negative 3. So if I plug negative 3 into my equation, I have negative 3 squared plus 6 times negative 3 plus 8. All I did was take this answer and plugged it back into my original equation. So negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8. PEMDAS here, 9 plus negative 18 is negative 9, plus 8 is negative 1. So my vertex is going to be located at negative 3, negative 1. All right, step 3 is going to be to find the y-intercept. So remember, the y-intercept is where it crosses the y-axis, so when x equals 0. So if I take my original equation and plug in 0 for x, then I'm going to solve for y. So I get 0 plus 8, which is just y equals 8. All right, so here are my important things so far. All right, step 4 is to choose one point not on the axis of symmetry. So if I quick sketch this out for you. All right, the axis of symmetry is at x equals negative 3. So that's going to be my dashed line right here at x equals negative 3. So this is going to be the middle of my parabola. All right, my vertex is at negative 3, negative 1, which is going to be right here. And I know that my intercept is at y equals 8. So I did not go up high enough. 1, 2, 3, 4, 5, 6, 7, 8. All right, so if we think about it, we know that this is our lowest point, and we know that it goes all the way up to where y equals 8. So how many spots away from 0 is our intercept? No, I'm sorry, not 0. How many spots away from our axis of symmetry is our intercept? Well, it's 1, 2, 3 spots away. So there's a couple ways you can do step 4, which is choose one x value not in the axis of symmetry. You could say, all right, well, I don't need to choose any points between 0 and -3 because I already know where that line is going. Or you could say, well, if I know I folded my parabola on this line, I need this other side to match. So this is 1, 2, 3 units away. So I could go 3 units away this way, 1, 2, 3, and I know I have to go up to -8. I could check to make sure I'm right. So this is at 1, 2, 3, 4, 5, -6, right? So what if I plug in -6 into my equation for part 4? So y equals -6 squared plus 6 times -6 plus 8. -6 squared is 36. 6 times -6 is -36 plus 8. 36 minus 36 is 0 plus 8. So I get y equals 8. So that's the point, -6, 8. All right, I graphed all of my important pieces. My graph is in the shape of a parabola. Yours curve should be a little bit smoother. Mine is more V-like. But that's how you graph a quadratic function, excuse me. That's how you graph a quadratic function in standard form. Let's do one more. So what if our function was y equals x squared plus 4x minus 2. So my a value is 1, what's in front of the x squared. My b value is 4, and my c value is -2. All right, step 1 is my axis of symmetry. My formula is x equals -b over 2a. Negative b would be -4 over 2 times 1. -4 over 2 is -2. All right, step 2 is the vertex. So I'm going to take my x equals -2 and plug it back into my quadratic formula, or quadratic function, excuse me. So -2 squared plus 4 times -2 minus 2. -2 squared is 4. 4 times -2 is -8 minus 2. 4 plus -8 is -4, and -4 minus 2 is -6. So my vertex is -2, -6. All right, step 3 is my y-intercept. So I'm going to plug in 0 for x. 0 squared plus 4 times 0 minus 2 is y equals -2. All right, let's graph those important parts right now. 2, 3, 4. All right, so my axis of symmetry is at x equals -2, which would be right here. All right, my vertex is at -2, -6. So -2, 3, 4, -6 would be right here. My y-intercept is at 0, -2. Right? I know this parabola is going to open up because it's a positive x squared. So step 4 is plug in another number that I don't already have. Or I could just mirror my image. So I know that this is my axis of symmetry. 2 spots away, or 2 units away, I'm at -2. So if I go 2 units in the other direction, right, here's my parabola. It should be fairly easy to graph these in ALEX as long as you are getting the U shape. Some of you, when you did this on your test, when it was like y equals 2x squared, you had this funky curve thing going. We've never actually seen a curve like this, so make sure that you don't have that as an answer on your homework or on your tests. All right, one other part of this lesson is the zeros of a quadratic function. We talked about this briefly when we were back in school. So remember, the zeros are where the graph crosses the x-axis, or when y equals 0. These quadratic functions can have 0, 1, or 2 zeros, which is kind of confusing, but basically it means you can have no solution, one solution, or two solutions for these quadratic functions. If your book tells you to use a graphing calculator, go ahead and use desmos.com. That's DESMOS.com. If you are doing some practice problems outside of ALEX. And so these are what the graphs would look like. This graph, see how it crosses the x-axis twice? So this would have two solutions. This graph crosses the x-axis once, so it would have one solution. And this graph never crosses the x-axis, so it would have no solution. If you would like some more practice graphing these, go ahead and do lesson practice on page 642. See you later.